Hello guys, welcome to today's class. And in the last example we were able to establish that when we have two quantities, x plus or minus delta x, and we have a y plus or minus delta y, and when we subtract them together, funny enough, the results that we get for this particular expression is that we'll have z plus or minus delta z will be equal to x minus y, okay, then plus or minus delta x plus delta y. So in other words, z itself is x minus y, and the absolute value, or the resultant absolute value, is delta x plus delta y. So y is delta z, not delta x minus delta y. So why? So that is the aim of this video. I want to explain that to us. So why is it that it is not like this? So I'm going to use two approaches to explain what is happening here. So first of all, example, I'm going to assume the properties of x to be such that it is 2 plus or minus 0.1. Then properties of y is such that it is 5 plus or minus 0.6, something like this. So for x, this is the measured x, and this is the associated approximate error, absolute error. And for y, this is the associated measured value. Then this is the absolute error and the approximate error. So first of all, when we are carrying out, let's say we want to start with addition now, Abi. So I want you to follow me. If we are adding these two values so that we'll get the resultant value, we concluded in the last class that the resultant value z plus delta z is simply x plus y, then plus or minus delta x plus delta y. So this is now going to correspond to x plus y, that's this value plus this value. So this 2 plus 5 gives me 7. So 7 plus or minus delta x plus delta y is 0.1 plus 0.6, and this is 0.7. So my z plus or minus delta z is 7 plus or minus 0.7. So let's actually interpret what this means. So 7 plus or minus 0.7 will give me range of numbers 7 minus 0.7 to 7 plus 0.7. And of course you agree with me that this is a 6.3 to a 7.7 over here. So the tolerance interval is actually what? This to this, 6.3 to 7.7. Is that okay? So this is what we got when we actually added these two ranges together. So using the formula that we established in the last class. Now I want you to know that even without for addition is a very simple and generic case. Even without you having to do all this first before you get your final range, you can actually spread these ranges and do the addition on this range and actually get your answer. For instance, x is given to us as 2 plus minus 0.1, and if we express this in interval form, this is a 2 minus 0.1 to 2 plus 0.1, and this is actually going to be what 2 minus 0.1 is a 1.9, and 2 plus 0.1 is what? A 2.1. So all the numbers between 1.9 and 2.1 satisfy these measurements. My y, on the other hand, is actually 5 plus or minus 0.6, and this corresponds to 5 minus 0.6 and 5 plus 0.6. So 5 minus 0.6 is going to be a 4.4 to a 5.6 over here. So now we want to find x plus y, is that okay, plus their corresponding deltas, okay, so that to probably correspond to our z plus or minus delta z. So we've already found our z plus or minus delta z. Theoretically, we found it to be this value over here, and when we spread it out, we got this range. So let's see if I add these ranges together. If I add these ranges together, 1.9, 2.1 plus 4.4, 5.6, am I going to get the same thing I got here? So let's try it out. So 1.9 plus 4.4 is definitely what is 6.3, okay, 6.3, and 2.1 plus 5.6 is definitely is 7.7. So yes, actually whenever we are adding two measured values, we discover that their ranges actually add up. Lower range to lower range add up, upper range to upper range add up, and we finally get our answer. So this is spreading of our errors using addition. Now I'm now going to carry out this same example for subtraction so that you see what is happening. So for subtraction, we establish that our z plus or minus delta z is going to be still the same thing as x plus or minus delta x, let me just explain it then, minus y plus or minus delta y. And in the last video, we established that z plus or minus delta z should satisfy x minus y, then plus or minus delta x plus delta y. So some of us will be expecting delta x to subtract delta y, but actually delta x and delta y are actually adding up. They are actually adding up themselves. So what is the underlying magic? So that's what I want to explain. So I'm still going to use the same analogy. X is our range of values 2 plus or minus 0.1, and y is my range of values 5 plus or minus 0.6. Of course, this has already given me 1.9 to 2.1 numbers satisfying this range, and this one has already given me 5 minus 0.6 is 4.4 to 5.6. So I want to subtract these two ranges, x minus y. So if I'm subtracting these two ranges, you discover that I have 1.9 and 2.1, okay, minus 4.4 then 5.6. Now see if I decide to do lower, upper. Now see what happens. See what happens here. If I decide to do lower minus lower, okay, what do you think will happen? So what do you think will happen? Can someone tell me? You discover that I will get a very funny value. For instance, I do 1.9 minus 4.4. I'm just going to toggle the on-screen calculator over here. 1.9 minus 4.4, 1.9 minus 4.4. So this is a negative 2.5. Then I do 2.1 minus 5.6, 2.1 minus 5.6, 2.1 minus 5.6, negative 3.5, so negative 3.5. So this is what I'm getting as my x minus y. So I want to check if this will correspond to, does it to z plus or minus delta z, where this is actually what, x minus y plus or minus delta x plus delta y. Does it correspond? If these two correspond, then what we did here is correct. If not, we need to figure out something else. So we have our z plus or minus delta z to be, in this case, x minus y. So x minus y in this case should be x minus y. What is our x? Our x is 2 and my y is 5. So 2 minus 5 plus or minus, then I have 0.1 plus 0.6. So that should be the answer of z, 0.1 plus 0.6. So 2 minus 5 is negative 3 plus or minus, this is a 0.7. So definitely in range form, this will be minus 3 minus 0.7 to minus 3 plus 0.7. Now check this out. Minus 3 minus 0.7 should add negatively and give me negative 3.7, and minus 3 plus 0.7 should be negative 2.3. Okay, so this should be z plus or minus delta z. But look at what we did, look at what we got here, and look at what we did here. Does it correspond? No. So something is wrong. And where is what is wrong? This is where what we did was wrong. So I need to actually correct this place so that we will know what is happening when we subtract ranges. When we subtract ranges, definitely there is a mathematics that you need to employ, which I'm going to show you today. So the first question is, what is the impact of a negative sign on a range? So previously, when we broke down x to its corresponding range, we had 1.9, 2.1. So x corresponded to 1.9 to 2.1, and our y corresponded to this range. Okay, y corresponded to this range. Y corresponded to this range 4.4 to 5.6. 4.4 to 5.6. So this is supposed to be the correct answer. So what are we getting wrong? Because when I subtract this range, I do this minus this and I got something else, this minus this and I got something else. So why is it not giving me what I want? So the reason it's not giving me what I want is because I am not understanding the mathematics that goes behind ranges. The mathematics of range is kind of like different from what you normally know before. Is that okay? It's kind of like different. So this is the reason why you have x minus y. In this case, it's now going to be 1.9, okay, 2.1 minus 4.4 to 5.6. Now you don't just come and say this minus this and this minus this. In fact, when you're doing range mathematics, just assume that minus does not exist, although it exists, but it's implicit. Now this is what I'm going to do. I'll change this particular stuff to x plus minus y. Is that okay? I'll change it to this form. So we'll now have 1.9, 2.1, then plus minus this range, minus 4.4, okay, minus open bracket 4.4 to 5.6. So the answer, the question, sorry, is what is the effect of a negative sign on ranges in mathematics? So let me try to demonstrate the effect of a negative sign on ranges in mathematics. So what is the effect of negative sign in ranges, or sorry, on ranges in mathematics? So assuming I have an interval defined in this way, x is less than or equal to I have an interval defined in this way. So this, I hope you know, is still the same thing as x is greater than a and x is less than b. In other words, I have a to b. Okay, so this is what this interval represents. So a less than x less than b. Now I want to see the effect of a negative sign on this particular interval. So in this case, this negative sign here, what effect does it have on this interval? Now this is the effect it has on this interval. should say that this is a pretty interesting discovery, and yeah, I actually took some time to figure it out after doing a lot of research and getting inspiration from God. Yeah, I actually figured it out. So this is what happens when you multiply, or when a negative sign interacts with with a range. Assuming you multiply through by -1, what happens? What is the effect of -1 on the size, on the direction of the inequality? It reverses the inequality, right? So multiply through by -1, multiply through by -1. So multiplying through by -1, I have negative a is greater than negative x. Is that okay? Then greater than negative b. So if you rearrange this particular stuff, is that okay? They're just trying to tell me that minus x is greater than minus b, and at the same time minus a is greater than, let me write it down, minus x is greater than minus b. Is that okay? So minus a is greater than minus x. In other words, if minus a is greater than minus x, that means minus x is less than minus a. So if I rewrite this particular interval according to this rule over here, the interval is now going to correspond to something like this: minus b less than minus x less than what? Minus a. Very good. So we have seen that if this is the positive aspect of this interval, the positive aspect of this interval translates to this, a minus b. Then the negative aspect of this interval translates to this version, minus b comma minus a. Do you understand? Now this is the summary of it. Whenever a negative sign interacts with an interval, okay, so this is the lower limit and this is the upper limit. Now how does this negative sign modifies this interval? The negative sign reverses the limits of that particular interval, and it doesn't just reverse the limits of that interval, it actually negates the values of the limits. Okay, it negates the values of the limit. So I'm going to copy out this particular point, and we're going to try to analyze it over here. Okay, so this is where we were before, and we want to apply what we just learned. So a negative sign, according to this explanation, it reverses what? The limits of a particular range, and it negates the range. So if the negative sign reverses the limit, I have 1.9, then 2.1, then plus. Then if I apply it to this place, the limit has been reversed. We have 5.6 and 4.4. It doesn't just reverse the limit, it actually negates the limit. So this minus sign does two things on this particular range: it reverses the limit and it negates the range as well, so that at this point I am now comfortable to apply the former technique of just adding. So my final result is now going to be 1.9 plus, okay, minus 5.6, which is plus minus 5.6, and to 2.1 plus minus 4.4. And of course, you know, this is still the same thing as saying 1.9 minus 5.6, 2.1 minus 4.4. So we're going to resolve it. 1.9 minus 5.6, 1.9 minus 5.6, negative 3.7. So my x minus y corresponds to negative 3.7 to 2.1 minus 4.4. 2.1 minus 4.4, negative 2.3, negative 2.3. So voila, this is what we got when we applied what this guy over here, the correct version. So this summary is that when you're subtracting, okay, So it actually proves our point, improves our point over here. And whenever you're subtracting two ranges of values, the size of the values are going to subtract, but the absolute value will add. Now, because the absolute value added, we came to this point. Okay, we subtracted the measured values and we got -3. Then the absolute value adding gave me this one over here. So when I spread the absolute values, I now got that z plus or minus delta z satisfy these numbers over here. Is that okay? Now I decided to test to see if I do it the normal way, maybe subtracting lower limits from lower limits, upper limits from upper limits. I'll still get this answer, but I failed because I didn't take note of something. So when I decided to take note of that thing, that I can actually convert this particular stuff to as if I'm adding, then I need to negate this particular range of values. So remember, when we negate a particular range of values, we are simply reversing the limit of that range. And in reversing the limit of that range, what are we doing again? We are actually adding a minus sign to the pre-existing lower and upper limits. So that was what we did in this particular point. We reversed the negative sign, has reversed the limit, and in the process of reversing the limit, it negated this guy and this guy. That's the 4.4 and the 5.6. Then we can now add. So we add this one to the negative version and we add this one to the negative version, and we get exactly the same thing that we got up here. Now check this out. This is where everything starts. Okay, this is our normal representation of a range. When we negate the range, in other words, multiplying by -1, okay, we discover that the limit has now been reversed. Not just that the limits were reversed, their sign also changed. Is that okay? So the negative x corresponds to this value, while the positive x corresponds to a to b. So we have minus b to minus a as negative x. So this is the summary of what we are doing. So x, now we have is z plus or minus delta z, and we said this is equal to x plus or minus delta x minus y plus or minus delta y. So the proof of this particular stuff will result in us getting our delta z to be the addition of delta x and delta y, because typically if we express this one in range from, I'll have x minus delta x up to x plus delta x, and minus, this is y minus delta y up to y plus delta y. Is that okay? So this is going to be x minus delta x up to x plus delta x, and I'll have minus, okay, I'll have a plus. So let me negate this particular range. In negating this range, what we observe, this part will flip over to this part, and because of flipping, the sign will change. So I'll now have minus y plus delta y and comma minus y minus delta y. So that's what a negative sign does to ranges. So if we now add negatively, I'll have this plus this is now going to be what? X minus delta x, then plus minus is still the same as minus y plus delta y. Okay, in a big bracket, then over to I have x plus delta x, and what will I have over here? So I have minus y minus delta y. Is that okay? So if we simplify this, we are going to get, or have x minus y, we now have minus delta x minus delta y on this place, and if you simplify this, you get x minus y, then you have plus delta x minus delta, oh, I actually missed something in this place. What did I miss? when we were opening these brackets, this minus sign is supposed to do minus minus, and this is supposed to be a plus. Sorry, so this is a plus delta y. Okay, so minus times y is minus y, minus times delta y is plus delta y. Okay, so that's the correction. So if we keep on solving like this, we are going to get x minus y and minus open brackets, you have delta x minus plus delta y. Okay, and minus, I have x minus y plus delta x plus delta y, like this. And this is your z plus or minus delta z. Of course, if you evaluate this thing carefully, you will discover that this is still the same thing as x minus y plus or minus open brackets delta x plus delta y. So this is the proof. So this is what happens when we subtract ranges of numbers. Okay, when we subtract ranges of numbers, the measured values will subtract, but the absolute value will be added together. So this is the proof, and I just decided to document it for those of you who want to understand why it was actually like this. So I hope you liked the video. I hope you understood. Like, subscribe, share, hit the notification bell so that you can stay updated, and don't forget to visit us next time. Follow the next video on the list. We're going to be solving examples. Or first of all, we are going to try to understand propagation of errors in multiplication and division, and we're going to dive into full examples as we try to understand errors and application of errors. Okay, so stay tuned and bye.